Okay, so we'll do problem number 6 together. We've got a bookshelf that's being dragged 12 meters across the floor with a rope. So the distance that the bookshelf is being dragged, the distance is 12 meters. And here's my bookshelf. I don't know why you drag a bookshelf across the floor with a rope, but apparently that's easier than picking it up, right? So here's my bookshelf. It's on its side. I've got a rope attached to it. I'm pulling it across the floor, and I pull it for 12 meters. And the tension in the rope that's attached to it is 400 newtons, and the rope makes an angle of 35 degrees to the horizontal. So far, so good? Okay, so remember, work equals force times distance, but the force that's important is the force that is parallel to the motion. So this total force isn't going to do us any good. We need the component of the force that's in the x direction. Remember, we've got tension like this, okay? And we need the x component of the force. So that means we have to come up with this component right here, that component. Anyone got any ideas what we should do to come up with that? Got to use trig, don't we? Yes. Okay, so what do you want me to do? Cosine, right? All right, so it's the tension times the cosine of 35 degrees will give me the tension in the x direction. That tension is the force that I'm applying. Remember, tension is a force through a rope or a spring or something like that, or a chain. A lot of times you'll do chains. When we did the pigs, it was the tension in the fishing line, okay? So you put that in, that's 400 newtons times cosine 35, and what do you get for the force? How much force is that? 327 newtons, yes?
Yes.
327 newtons. All right, so that is the tension in the x direction, 327.6 newtons. And if work is force times distance, what's the distance? It's 12 meters. So you multiply that by 12 times 12. And what do you get? We'd have to round that up if you want to, right? And so 3,932 joules. That would be answer C. Questions?